Uranus. The ice giant is seemingly desolate. Marble-like icy blue-gray sphere in the far reaches of the solar system is anything but barren. In fact, there are some fascinating facts about this planet that make it unlike anything else we've seen before. The first unique aspect of Uranus is its name. All other planets are named after Roman deities, except for Uranus, which is named after the Greek god of the sky, Uranus. The Latinized version of this name, Uranus, is what we use today. Uranus is extremely special in the way it rotates in its orbit. It is the 7th planet from the Sun, orbiting at an average distance of about 19.2 astronomical units all, meaning it's over 19 times further from the Sun than our Earth. This distance varies throughout its orbit by 1.80. The largest variation of any planet. This distant orbit means that Uranus is frigid, with temperatures around 220 degrees Celsius (364 degrees Fahrenheit), making it the coldest planet in the solar system. Its year lasts 84 Earth years. When it was first observed, astronomers tried to predict its orbit, however, realized it didn't follow predictions and concluded that another planet must be exerting gravitational influence on it. They mathematically predicted where this planet would be, leading to the discovery of Neptune. Interestingly, similar theories surround the yet-to-be-discovered planet X or Planet 9, as some objects in our solar system's far reaches are not in their expected locations, suggesting another planet's gravitational influence. The search is unable until now. A truly fascinating thing about Uranus is its rotation. Most planets rotate on a plane aligned with the solar system, but Uranus is the exception. Instead of rotating, naturally rolls on its side for most of its year. You see, it's axial to 97 degrees, which means its seasons are wild compared to the other planets. During the solstices, or points in the year when the sun is at its highest or lowest point in the sky, one hemisphere of the planet is always facing the sun while the other is submerged in darkness. It's as if the planet is rolling forward along its orbit with only a narrow strip near the equator experiencing day and night during this time. However, the sun only rises right above the horizon, while the poles experience 42 continuous years hotness followed by 42 years of daylight. Uranus rotates once every 17 hours and 14 minutes. However, because its surface is not solid, some parts of the atmosphere rotate faster than others due to strong winds. Some parts can complete a full rotation of the planet in just 14 hours. This odd rotation may tilt to make it the only planet in the solar system that receives more energy from the sun at its poles than our average at its equator. Yet, for some reason, Uranus' equator, despite receiving less energy, is warmer than its poles, and no one really knows why. There are also speculations about why Uranus does not rotate like its neighbors. One theory widely accepted by the scientific community suggests that long ago, a live planet-sized object collided with Uranus, knocking its rotational motion sideways. How big is Uranus? Really? It is the smallest of the gas giants with a mass about 14.5 times that of Earth, compared to Neptune's 17 times Earth's mass. Yet, its diameter is slightly larger than Neptune's at 50.700 kilometers. About 4 times that of Earth, because this mass is spread over a larger area. The gravity on Uranus is just slightly less than on Earth at 0.89, which would make you feel relatively comfortable. What is Uranus made of? It's thought to have a core slightly smaller than Earth's made of silicate rock, surrounded by a mantle of water, ammonia, and methane ices. Although cold ices, this mantle is actually very hot, nearing 5,000 degrees Celsius and resembling a liquid ocean surrounding the core. So, to call Uranus a gas giant might be a bit misleading. It's certainly not. Gas is very far down. Its atmosphere is actually very thin when compared, consisting only of about 0.5 Earth masses. Most of Uranus's mass lies in its core and the surrounding mantle. The planet's atmosphere is composed mainly of helium, hydrogen, and 2.3% methane, topped with a layer of clouds. It's the methane that gives Uranus its blue-green color. An interesting point, is that some models suggest that the pressures at the bottom of Uranus's mantle are sufficient to break down methane molecules and compress the carbon atoms from methane into diamonds. These diamonds then rain through the mantle like hailstones. The base of the mantle may be an ocean of liquid diamond or carbon, with solid diamonds floating in it. Now, let's step off the planet a bit to look at its ring system. Like all the larger planets in our solar system, Uranus has a set of rings. It has 13 known rings that are very dark and narrow, most being only a few kilometers wide, and they are believed to be no more than 600 million years old, which is quite young compared to Uranus itself. These rings consist of extremely small particles. The largest particles are only a few meters in diameter, made of water, ice, and organic materials processed by radiation. These rings are not very reflective, meaning they are darker than wet soil. As for Uranus moons, the planet has 27 known moons, named after characters from the literature of Shakespeare and Pope. These moons are categorized into 3 groups: 13 moons, 5 major moons, and 9 irregular moons. Intermoons are closely but Uranus's rings, and may have provided material for the rings. The largest of these intermoons is Puck, with a diameter of just 162 kilometers. Is the only intermoon by Voyager 2, interestingly. These intermoons are constantly colliding with each other, and the system seems to be quite unstable. There is a high likelihood they may collide again in the future. The 5 major moons, in order of distance from Uranus, or Miranda, Ariel, Rumbriel, Titania, and Oberon. Titania is the largest moon of Uranus, and the largest moon in the solar system, with a diameter of 1,600 kilometers. Once again, as can be seen, these are very dark objects. Umbriel is the darkest, except for Miranda, which is primarily composed of water ice. The rest are thought to be a mixture of water and rock. These moons might have differentiated interiors, meaning the core of rocky material with an icy mantle. It's even possible they have subsurface oceans of liquid water between their core and mantle. The intriguing aspect of the larger moons is that their axial tilt is similar to Uranus, meaning that during the solstice, the sun would circle the sky without ever setting. The 9 irregular moons are likely captured objects, varying in size from about 20 kilometers to the largest, Syrinx, which has a diameter of roughly 200 kilometers. Lastly, let's discuss Uranus's congenital magnetosphere. Uranus seasons are unique in the solar system due to its extreme axial tilt. Telescope technology only allows us a faint view of surface details on Uranus over the past few decades. It means we can't say for sure whether there are seasonal changes on Uranus. However, what has been observed is that as the planet approaches its solstice points, it brightens up and forms a bright color that moves away from the solstice point. These brightenings are thought to be due to denser methane clouds. Although the reason remains unclear, the seasons also seem to affect storms in the upper atmosphere. Storms were once rare on Uranus compared to other gas giants, but they are thought to be brought about by the changes of the seasons. With improvements in telescope technology, we can also observe dense cloud bands around the planet, similar to the other gas giants. However, these are mostly visible in the infrared spectrum, which is why Voyager 2 couldn't show us this invisible light. In these infrared images, you can also see small storms scattered everywhere. Another unique feature of Uranus is its unusual magnetosphere. Typically, a planet's magnetosphere originates from its geometric center, but it's not the case with Uranus. Moreover, it does not align with the axis of rotation, being offset by 59 degrees. This unusual positioning means that the magnetosphere at Uranus' northern pole is much stronger than at the southern pole. One hypothesis that the liquid diamond ocean might be deflecting the magnetosphere, or perhaps it's not the core but the thin mantle layer that generates the magnetosphere. Uranus' magnetosphere is comparable to Earth's, and due to its unusual rotation, its magnetic tail twists into millions of kilometers into space to this day. Uranus remains a mystery with countless stories and myths. Scientists have dedicated their lives to studying this planet. while others believe it's a dangerous destination to explore. Despite all efforts, the mystery of Uranus continues to swirl in space and time, making it an indispensable part of human understanding and imagination.